Okay, so basically today I discuss about that your topic. Mainly you want to learn about that urban global studies factors, and there are a lot of factors. Okay, I already read all of factors.
Yeah,
So today I try to discuss
yeah, yeah.
about this type of factor and what types of data source we need to use for GIS and remote sensing
Okay.
to get this type of
Uh-huh.
data. Okay, we also discuss about that, then you can get the better idea.
Okay, to be happy for.
Okay, so let's go. So okay, let me share my screen. Just a minute. So for the urban studies, we try to add you add the different types of factors. Okay, social economic factor or different types of factor we try to add in here. So I will try to show you that all of factor one by one and what types of data we need to use for each factor. We also discuss about that and also try to get this type of data from remote sensing or GIS analysis. Okay, for the study area. So let me open my code editor.
Okay.
Okay, so first of all, we talk about that one factor. It's called that social
Yeah. I
economic
know. So
factor.
sorry.
The first item, social economic factors. So in this factor, you try to add some variable. Suppose first variable you add population count. Okay, population count. So this population count, we can get the remote
Yeah, for sure.
sensing data. This data source data set name is, it's called the world of global population. So from here we can easily get
Okay.
the population count data, and then population, another for population density. Okay, so population density, we can also measurement the density. Suppose per square kilometer area how much people live, we try to compute from the population count. So because we have a area, suppose I have a city's area or any specific boundary, so now I already know how much people live here. Mainly it's called the population count,
Mm-hmm.
how much people live here. So then we can easily compute the population density from the population count, because I have the number of people as well as I have the area of the people, area of this place. Then we can simply divide it and we can get the population density. As
Yeah,
well
yeah.
as another
The
factor you
population
try to
density.
add, it's called the GDP. Okay, GDP,
Yeah,
Google
GDP.
Earth Engine, it's directly not provide the GDP data, but we can also use the another
Okay.
proxy data. It's called that nighttime lights. Okay, this data set name, it's called that
Yeah, nighttime light. I
yeah,
thought they provided it.
night time lights as a proxy of GDP. Okay, so basically in the nighttime activity, we can easily measurement using this data. It's called the nighttime lights. It's come from BIRS, Breeze Night Light. So first of all, we discuss about this three factor. Okay, we try to compute. Okay, then we just work with. We can add the also other factor. Suppose climate factor. Then okay, so for the climate. Okay, so first of all, it is discuss about the data set. Then we just go to the code, because I already developed the one code. Then it will be more better. Then we can easily get the result. And then third number factor you try to add. It's called that climate factor. Okay, we also add the different types of climate. Suppose mean annual temperature. So I'll also write the comment, it will be more better. Suppose it's called the climatic or climate factors for urban studies. In the climate factors, first item you add, it's called the MAT, mainly mean annual temperature.
Annual
Okay,
temperature.
yeah, so mean
Yeah.
annual temperature. So this mean annual temperature, we can easily get one data set. It's called that world bioclimatic variable. Okay, world clim clim variable 2, or world bioclimatic variable. You can easily get the mean annual temperature, as well as we can also get another, it's called the map. So map, basically you just add the mean annual precipitation. Okay, so it's called the mean
Mm.
uh, annual precipitation. Okay, I think you cannot share my screen. Let's just a minute. Just stop. Okay, just let me. I think some networking issue. That's why it just let me share the screen again.
Okay.
Okay, so now can you see my screen? Yeah. Okay, so it's called the annual uh, mean annual precipitation. So this data set we can also get from world by it's different source we find out. Suppose if you want, you can use the CHARPS satellite data, mainly CHARPS rainfall data. We can also get this data worldwide is available. Okay, mean annual precipitation. Then we also another factor we add, it's called the air temperature. Okay, so air temperature. This air temperature data we can easily get from it's called the ERA5 land. Okay, it's one kind of reanalysis data. So we can easily find out this type of air temperature. Then you also add another factor, it's called the moisture stress index. Okay, moisture,
yeah, for sure, that I need it very much.
Yeah, stress index. And I try to add all of factor you add in your paper. So I'll try to show you that, and then we can easily get the idea.
Yeah, for sure.
Then it basically moisture stress index we can get from the MODIS dataset. MODIS evapotranspiration. Okay, from this we can get it.
Dataset.
And then fifth, you also add another. It's called the wind direction. It also possible. You also get it from ER5 wind data. ER5 wind data. You also get this type of data. So this type of climate factor you also add. Then you also add the wind speed and direction. Okay, it's also possible to identify for wind speed and direction of wind. We can also get that from the remote sensing. So I also write it. It's a wind speed and direction of wind. So basically you find out the U component wind. We find out it's from this data set ER5. We can easily find out ERA5. Oh, sorry, it's come ECMWF. Sorry, it's come from ECMWF. And when you search, suppose you simply search here ECMWF, so then we can easily get this type of data. You can see ECMWF. So any data set which I just write the name. So when you search this type of keyword, simply search on the top, then we can easily find out. So then I also show you that how we can easily work this type of data from here, and then get the data for every cities or in the world or anywhere, and globally it's available. No problem. You can easily get this type of data. So you can see that's the bands. Then how to use this type of data, then you can get the better idea. Okay, so this is ECMWF data set, U component. Then we also need that another, it's called the V component for the direction. So V component wind. It's also come from same ECMWF data source. And then wind speed, simply calculate, just apply formula square root of U square plus V square, because this is the U, this is the V. So when I can get the U and V, then I can easily compute the wind speed. Just apply the speed formula. So square root U square plus V square, then we can easily get when I have the U and V, then we easily compare the wind speed also. Okay, so this is the wind speed and wind direction. Then we have also another factor, it's called the in the soil. Okay, just
soil property.
Yeah, soil property. Yeah. So I think soil property, there are a lot of property we try to add in here. Soil texture. Okay, so let me show you that. also available in the Google
Okay.
Earth Engine. This type of data easily find out. So soil proper soil properties. In this case, we can easily compute the soil texture. Soil texture, it's available. The data set, it's called the open land open land map soil texture classes. Okay, so we can easily find out from this soil texture information worldwide is available. Then we'll also find the bark density. So we also find out that open land soil bank cities is also about that. No problem, it was available from the same
On the same
open land maps. Okay, we also find out.
Finland map. Okay.
Then water retention. Okay, so it also come from the open land. So okay, let me show you the another data source. Just a minute. So you can simply search on the Google. Suppose Google Earth Engine. Google Earth Engine community data catalog. Simply search on the Google. Then we find out that one website. So this website we find out. So from this website we can easily get lot of data set. Okay, and this type of data we can easily use on the Google Earth Engine. So here you can see, so this is the data theme. So different types of data theme we can easily find out. You can see this is the population and socioeconomic data. This is the one kind of theme. So
Okay.
under this theme I find out the lot of data. If you simply click on here, then we find out the all of data related to the population and socioeconomic. This is the geophysical and biological and biogeochemical. So just click on here, then I can get all of data related to the theme. So you can see the elevation and bathymetric soil properties. I need suppose soil properties. Just click on the soil properties. So then I find out all of soil properties data. Suppose soil grids information, soil properties, soil probabilistic soil properties, then different types of global soil salinity map, global soil bioclimatic variable, harmonized world soil. Okay, so different types of data we find out from this. Also global land use land cover data. Okay, also in the regional land use land cover hydrology data. Then you can see the ocean and shoreline data, then agriculture and vegetation forestry data. So it provides a lot of data set globally. Some data is regionally, but maximum is the globally find out in here. So we
So
also
can I
try,
get this data set can I get this data by using the geographic coordinate?
yes, it also possible. So this type of
Thank you very
data we can easily use the Google Earth Engine. Okay, so this is the another source of Google Earth Engine data catalog. It's called the community data catalog. So in the community data catalog we can easily use this type of data in Google Earth Engine code editor. We can simply import this type of data and also work and create the map or make the analysis. We can easily do using the Google Earth Engine code editor.
Okay.
So I'll also show you this, also get the some data also from here and then try to show you that. And you can, okay, if you check suppose another, so this is the okay, so this is the Earth Engine data catalog. Okay, so this is the Earth Engine data catalog, but previous one it was Google Earth Engine community data catalog. Okay, so it's the different.
Okay.
So this is the Earth Engine data catalog, and Earth Engine community data catalog is the different. So in the community data catalog, different developer, they create the different types of data set and they can easily upload this type of data, and further any other people they can easily use this type of data. Okay, but in the Earth Engine data catalog we can easily find out some satellite imagery, suppose Landsat, Sentinel, MODIS, or other types of satellite imagery. But this type of community data catalog, it's provide you the ready-made product. Suppose different types of analysis. So this type of analysis is already done. So now we find out the ready-made product, different types of data. Not need any kinds of analysis. Just we are use this type of data and get the result for worldwide.
Okay. Oh my God.
Yeah.
That is very, very helpful sources.
Yeah. So this is the water retention. We also get, no problem. Then
Okay.
Then we also find out that soil profile or soil depth. Okay, soil depth information we also get. And then suppose another soil PS. Okay, soil PS from the community we also get from here. Then we also get from suppose organic carbon.
Yeah, for sure.
Carbon. then total carbon, total nitrogen, phosphorus, okay, and suppose
Okay.
electrical
It will be
conductivity.
helpful.
Yeah. So this type of data is easily available, but not for the in real time. Some data set is not available for the real time, but past time it is also available. Some data set we also find out.
Okay. Okay. I understand. But using this coordinate, I can get this data from
Yeah.
from this data set that are available.
Yeah, it also available, no problem. But for the some data
Okay,
set, suppose
okay.
you need the near real time, suppose present time, 2025 month of January. So I think some data set is not available for the more real time, but past time you find out easily. No problem.
Actually, when I cannot get it there, where I will not get the real data time, I can use maybe the data that can be present, or maybe that can approach the period dated with the collection time.
Yeah. And
Yeah.
then we also add some other factors after soil properties. We also add suppose topographic and urbanization indices. So topographic and urbanization indices, there are a lot of factors we can include. Suppose topographic and urbanization indices. So there are a lot of factor we can consider. Suppose urban green path we can also consider. Suppose urban green
Good.
space or area, okay, it also available, we can easily do from that. And then suppose building density, okay, building
sure. I need this.
density. And suppose road network density, road network
Yeah, for sure. I need it
density.
for the where the
Yeah. And then suppose and pollution density, suppose pollution density.
urban
So
pollution.
yeah, urban
Oh
pollution
my.
density. So for that we also
Okay.
use some air quality factors, suppose air pollutants, suppose nitrogen dioxide or also sulfur dioxide or methane or carbon monoxide. So this type of gases we can
Yeah, for
easily
sure.
get from this pollution index or urban pollution index. As well as if for the urban
Okay.
index you can also add suppose other factor, it's called the um, uh, urban heat island. It also possible, you can also identify urban heat island. Then urban lighting intensity, urban lighting intensity, okay. Then urbanization expansion,
That I needed to. That is one of the crucial one.
urbanization
Urban expansion.
expansion.
That is the crucial one that I need to use.
Then as well as also we can compute for another index, is very important, it's called the ecosystem health index. Ecosystem health index.
Ecosystem health index.
Yeah. Then vegetation health index, it's not much important, you can also add vegetation health index, no problem. And then
Yeah, for it will be important.
anthropogenic emission. So emission, basically you can get the different emission you can display.
Emissions.
Suppose
Yeah, for sure.
carbon dioxide emission, suppose methane you can also add for emission. Then nitrogen dioxide or sulfur dioxide.
Nitrogen.
Yeah.
So there is a data that I count maybe I can be used for that for the particle
Then
matters.
water vapor you can also add, water vapor or sulfur dioxide. Sulfur dioxide. So different types of gases is available.
Sulfur dioxide.
As well as heavy metal soil. So the heavy metal concentration data set, it's not available directly in Google Earth Engine, but we can also use the metal available by open land map, okay, to arsenic or cadmium, chromium, copper. So this type of thing also available.
Yeah, no problem.
and heavy metal.
This that related with heavy metals are available, right?
Uh,
Yeah, it can be helpful.
okay, so we try to, because there are a lot of things, so we try to discuss how we can work this type of vector. Again, create the map or get the data for the coordinate, a specific coordinate. Okay, so let me open a new code editor.
Sir,
Yeah, please.
so may I ask a question?
Please.
There is one of important data that I asked
Yeah.
related with calculating in the sources. It means to calculate maybe the distance, maybe the distance, maybe and the number of important source of these antibiotic resistant genes like hospital.
Yeah,
Maybe we
so
discussed it the last time.
okay, so it's
Hospital.
called the
Did you
Euclidean
remember?
distance. Okay, suppose distance to road or distance to hospital or distance to building.
Distance is possible.
Yeah, it also
Distance to
possible.
water.
Yeah.
Industrial zone.
Yeah, it also
That one maybe it's crucial that I needed to use also for making correlation with the abundance of these antibiotic resistant genes in my microbiome community.
Yeah.
Especially the pathogenic one.
Yeah, it also possible. So okay, let me show you the one example for that. Distance to, how we can easily compute the distance to road or distance to river, distance to water body. It also possible. So further we need the line. Suppose when you work with the road, we need the road line. Okay, so when you work with suppose river, we need the river network or river shapefile.
Okay.
So this type of river network or road line, then we can easily get this type of distance to river, distance to road. Okay, this type of things is possible to create.
Okay, understand.
Suppose let me show you the one example. Okay, just share my screen. So this is the one kind of code. Okay, let me show you the result. So this is the result for distance to river. Okay, this is the distance to river in Bangladesh. So for that, first of all, I need the river network in Bangladesh. Okay, suppose this is the kind of whole region, okay, whole country boundary of Bangladesh. So this is the distance to river map. And if you check the result, so in this result, if you check this type of red color, it's indicating about that high distance from the river. Okay, this is the red color indicating about high distance. And if you check the legend, it will be more better. And you can check the, suppose this is the river. And if you check the river network, so this is the river network. So this type of blue line, it's indicating about the river. Okay, it's a river network. So this is important. Suppose when you work with the distance to river or distance to road, then first of all we need the river network. We need to generate river network. Okay, so then after the river network, we simply compute the Euclidean distance. Okay, we compute the Euclidean distance, and then we compute the distance to river. And you can check, this is the map. So this is the map. So in this map, we find out that this type of blue color indicating about the very close to the river. This type of blue color, it's indicating about the very close to the river. Then suppose green color, then yellow color, then red color. Okay, so this is, you can check the reason. Just show you the.
I understand.
Okay, so you can see the color combination. So blue color is indicating about the more close to the river. Okay, then green color far from the river, then yellow color is more far from the river, and red is the very high far from the river.
Very far.
Yeah, so this is this type we can easily get. But for that we need that this type of river network, or need the road network. When you work with the road, then we need the road network. And when you work, and further you can also export. Suppose this map you can easily export as a GeoTIFF file format, and you can also get the data so as a raster data or GeoTIFF file format. You can also work, no problem.
I tried using street map, but I thought the result I got, I did not, they don't have the high accuracy.
So this is okay. Basically, basically we can also get the some data from online to get the shape file for the specific country. Suppose you can see. Let me show you that. Just open the code. So this is the distance to road map from a specific district. So you can see this is the distance to road map. So this is the distance to road map, and this is to rivers. So this is the distance to road. So for that I need the road shape file, and you can easily get this type of shape file from the source. Let me show you the source, then you will also download the data individually. For a specific country we can get this type of data. Simply search, suppose I need the data for Bangladesh. I simply search here, suppose Bangladesh river shape file. Simply search, then we can get, you can see humanitarian data exchange. So this is the website, first website. So Bangladesh river shape file you can easily get from here, all of river in Bangladesh. So just click on here, then we can easily download the shape file from all of river network in Bangladesh. We find out. So you can see this is the river shape file. Okay, so simply download this shape file, and further this shape file just import in the Google Earth engine and then work to create the distance to river map.
Oh, it means I will need to download all the shape file that I need
Yeah.
for all the study that I need to conduct.
Yeah. Suppose you need another country, simply search here. Suppose I need the result for, suppose, India river shape file. Just simply run. So you can see shape file of rivers. So we can find out some different link, because different link is stored the different types of data. So you can see, you can easily download the zip file format. Okay, simply download this type of data, then we can easily get for the river shape file in India. Okay, or any country, simply search, then you can easily get the result for every country.
For every country.
It's available, no problem. As well as if you simply search here, suppose hydro sheds. Hydro sheds data download. Simply search hydro sheds. This is the website, www.hydrosheds.org. So we can also get the lot of hydrological data, suppose river network or drainage basin. So it provides the, you can see that hydro sheds, hydro atlas, hydro basin, hydro river, hydro lake. Suppose I need the river, so click on the hydro rivers. So you can see the hydro rivers. We find out that globally, all of whole world, we find out the all of hydro river shape file or shape data we find. You can see now. You can see. So you need the data, suppose global. So simply download the global. Then we can get the global river network shape file. Suppose you need only for the Africa region or Africa continent, then download the Africa continent. You need only for the Asia, or you need the northern Canada, just simply download for a specific. So you can easily get, you can see all of regional data set you can easily get from here. It's a your hydro rivers. So we find out hydro rivers data, we find out shape file, we find out river network for globally. So from the hydro shed we can also get this type of data for globally, or a specific country, or Africa, Asia, Australia, Greenland, South America. So global data set is available. You can easily download this type of data.
Okay. Then there I have problem.
Please.
If I was planning to calculate like the water body in general, or the file I sent to you.
Okay.
I need to be specific. For river, maybe some point is taken near lake, others are taken near the river, others are taken maybe near the landfill. Then what should I do at this point?
Okay, so now where is your study area? Mainly, which is is the ROI for which area?
Yeah, it's urban area.
For which country?
You said?
Mainly which country, or global, all of urban?
Yeah, it's for global. Maybe I will select some study.
Yes, so that's why it creates some problem. But when you choose some specific countries, okay, or is for specific cities, then hope it will be okay. There is no problem. Okay, but now when you work with the globally urban, suppose some urban area near to the lake, some urban area near to the river, so then it's just more complex. It gets some complex. So then you just choose, suppose, a specific urban. Okay, then I hope it will be more better research work.
It was a global study. I need to use all this point maybe for calculating the distance.
Yeah.
I could select few cities.
Yes. Then just work
Because
only for this type
calculating
of few
this,
cities, it will be more better.
because calculating this distance, I thought it can take maybe not no more than 1 month.
Yeah.
More than 1 month.
Yes. Okay, so we discussed, so let's go. Okay, so let's wait to start. So first of all, you need to import a shape file. Suppose I want to work for, suppose Bangladesh, all of cities in Bangladesh I need to work. So further, I need to import the Bangladesh boundary shape file or boundary polygon. So this polygon I can easily find out from USDOS website. So it's provide you the international arts international boundary polygon. You can easily find out from here. Just import. So this is the data set. It just stored all of international country boundary polygon in the world. We find out. Okay. So from here, suppose I want to work with for Bangladesh cities, all of Bangladesh city or Bangladesh boundary. So for that, I simply take a variable, suppose RY, and call the table. So this table I want to filter and choose a specific country boundary of Bangladesh. So Earth Engine dot filter.
I can't
Oh,
say
yes.
I'm say I'm
Okay.
I'm almost okay. I
Okay.
see.
So equal. Suppose I put here country NA, and I put the country name, suppose Bangladesh. So now what happened? So now this table, it is stored the all of international country boundary polygon in the world. So just I call the table. So this table I want to filter. So how I can filter? Where country name equal to Bangladesh. Okay, so now what happened? So now this variable is stored the Bangladesh country boundary polygon. Suppose I want to display it. Suppose map.add layer and call the RY. So now if I run the code, so now it added the layer of Bangladesh boundary, but it not focus. But I just focus on my shape file. So just apply the another function, map.center object is RY. I put the zoom level, suppose 10, and now run the code. So now it directly focus on Bangladesh boundary. So we find out the Bangladesh boundary. So not only Bangladesh, any country boundary, suppose you need, so you can simply write the name of this country boundary name. Suppose I need the data for another country boundary. Suppose I need the data for Australia. So just put here Australia. So now run the code. So now we find out the Australia country boundary polygon. Okay. So all of country boundary polygon you can easily get from this data set. So now suppose you just work with the you want to make, suppose, population density or all of factor. You try to check for individual country. So you just simply change the country name. We can easily get the result for every country. We find out. Suppose I need this result, or if you want, you can also do for the city-wise analysis, because you want to work for the city. So it's a country boundary polygon. Suppose you want to work for the city. So how I can get the city boundary? So it's a country boundary, but I need, suppose, city boundary. Okay. So for the city boundary, we have just used another data set. It's called FAO. So this data set mainly stored the all of secondary level. You can see the FAO global administrative second level. Okay, just I import. So this is second level, just I import. So now suppose I want to filter the second level mainly district. Okay, district. Just I copy the table 2 and then paste here. Suppose in that, from the table 2 I choose the, okay, you can get the information from here. Just click on here on this data, mainly administration level 2. From the table scheme we can get the data. You can see the administrative level 2. So this variable, it is stored all of cities in the world. We find out. Just I copy and paste here, and then I put the name. Suppose I need it for Dhaka city. Just I put the Dhaka district, and now run the code. So now I can get the boundary only for Dhaka district. We find out. So any city, we can simply write the name, then we can get the result for these cities. Because this table 2, this variable is stored all of international country boundary, mainly district level boundary. We find out. Suppose I need the another district in Bangladesh. Suppose I put here the another district name is the select, just run the code. So now I can get the result for select. So this is the another district boundary in the select.
Okay.
That was I need for Shillong. Okay, I think this is not the proper name of this district, so that is this type of, or I need suppose Ranchi. To find out this type of result. Okay, so now how I can check the population count? Suppose I want to check for this study area population density, or I want to check suppose population count. So for that we'll just use the one data set. It's called the world population. Just simply search world pop. So we find out world population, or you can check. I already show you the data set name. Okay, let me check the name again. So this is the world population, world population, global population. Yeah, just I copy the name. So this one, yeah, same. So you find out this is the data set, and this data set available population. This is the one kind of band, and it estimate the number of people residing in the east grid cell. Okay, east grid cell estimated how many people live
Yeah,
on
I know,
east
I
cell.
understand.
So this data we try to use. So how I can use the data? So very easy, just copy the snippet id, just copy the snippet id, and then
Okay.
paste. Suppose I just paste in here. Okay, then just give a variable name. Suppose take a variable name, or this data set including the population age, sex, and also constant and others. Okay, so I think this is another data. It's also related to the population age or others. Just a minute, let me check the proper data link. World population. Okay. This one, world population. Okay, let me check. Yeah, this one. So world population. So it's data global hydrogen content data, human population distribution. So this data set estimate same. So just I use it. Just I copy the new snippet id and change it. Just paste here, and then give a name. Suppose I put the name is pop my data set. So this data set I simply filter. Suppose this data set I need for a specific boundary or a specific cities or branching. Okay, just I paste here, and then just apply the dot filter. Suppose filter bounds function with my study area ROI, and this data set, let's check the time period. It's available from 2000 to 2021. You can see this data set is not available for near real time. Okay, so we can get the data set from the 2000 to 2000 because it's a raster imagery, further it's
No
not
problem. I can,
and then
you
I
can use
just
this that
yeah,
said. Can this do it valid?
yeah. So now we just simply put the dot. Suppose I compute the total population sum and further clip with my stereo area ROI. So now if I just add the layer, suppose map dot add layer, and then call the population dataset. So now we find out this, it's added another map, population distribution for this study area, and from here we can easily get the idea where is the high dense or high count population area or low count population is easily find out. So this is the result we find out, look like that. So now we try to add the color to, or you can also export this type of data as a GeoTIFF file format to create the more better map using ArcMap or QGIS software. So in this case, suppose I want to just stressing the data 90%. So now further we just add the color plated to add to check the distribution, or I can apply just a minute, add. Okay, just a minute. let me just add from here. Suppose just I add the, so I put the mean range, suppose 67, and max range, suppose 3885, and add the plated. It's optional, it just show the visualization only. Suppose I want to add, suppose low visualization, where is the low count population, show as a pink color. Get it, then show suppose yellow color, then show suppose green color, and suppose high, show the red color. So now run the code. So now this color is set in the map. So from this we can easily get the idea. So if you check which area we find out the more high population dense, so we find out basically this type of place, high count of population. Okay, this is the place we find out. Again, this type of pink color is not much. Okay, this type of red is very high. Then we find out the green, then yellow, and finally pink color, and also get some yellow color also. If you want to check, suppose how many population for a specific grid, or so for that, just click on the inspector tab and click. So now we find it for this coordinate, or for this cell, we find out that how many population count 2000. Find out. So this is the one city, Ranchi city. Suppose I need the result for another city. Suppose I need the result for Dhaka city. So I simply put here the another city name, Dhaka. So now run the code. So now we find out this result for the, if you check, we find out the Dhaka city, what the population densities. We find out this type of red color. It's indicating about the count of population is very high. Okay, this type of place. Okay, and this type of green color, then yellow color, and then pink color. Okay, low population count. So we find out this place have the high population count.
Yeah, I see.
So this is the result. Suppose this type of result you can also export as a GeoTIFF file format, and it marks only for your, you can see some place it show the blank. So suppose this type of place have the barren land or water body, or any place where the people is not live.
Okay.
Okay, but also build up area.
Okay.
Or sorry, build this type of place, we find out this type of things. It's just automatically. So any cities, if you simply search the city's name, then we can easily get the map look like that. Okay, so this is the population.
Then how if you have like,
yeah,
how if you have like 10 cities and you need to export this data,
yeah,
maybe in a CSV file.
Okay, so this data
Then
we
give me some
can,
context,
okay,
maybe.
so this data basically it's a raster data. So this data we can easily download on the GeoTIFF file format. Okay, GeoTIFF file.
Okay.
GeoTIFF file basically raster format. We can easily download the data.
Yeah, I know, a last format.
Yeah.
You can download from the last format, then extract from using like a or Python codes.
Yeah, it also possible. This raster. So this is the population. This is the population count we find out. But I also need suppose population density. Okay, so how I can compute the population density? So for the population density, basically we are just use a formula. So this formula is, if I write suppose population density equal, you can write the formula is people, number of people divided by area. Okay, suppose area.
Yeah.
So now I have the count. This is the result. Basically this result display the count. So every cell, how much people live, we find out from this map. So now if I just compute the total area of the Dhaka city boundary or Dhaka district boundary, then we can easily compute the population density for our study area. So let's go try to compute the population density, and further we need the population. Okay, I think okay, load. Okay, so if the meeting is the end, I will send another link.
Okay.
So now population density, first of all we need to calculate the area. Okay, so take a variable, suppose pixel area. So just apply ee dot image dot pixel area. So basically it's compute the pixel area, unit is meter square. Okay, and we need to compute the area in the kilometer. Okay, we just compute the area per people area kilometer square. Okay, this is the density formula. So just we need to convert the area also. So take a variable, suppose population density equal, just I call the population dataset, this dataset divided by total area, basically this pixel area okay
I can't hear you.
okay, can you hear me now? Yeah, and then apply the
Yeah.
reduce region, because we need the total area. Suppose pixel area, we need to total area. So for that we apply the reduce region. So let me check for reduce region. So this is the function we need to apply. So just I copy and paste all of those. Just make a curly bracket start and curly bracket int. So first of all, reducer. So I want to calculate the total area. So apply ee dot reducer dot sum total area. Geometry, it's my shapefile variable name. Basically Dhaka city boundary, straight the ROI. Just I copy the ROI and paste here. So scale is the resolution of your satellite imagery. It's a 92 point something or 92 I put, or what the resolution, check the from here. So this resolution is 92.77 meter, almost 92, no problem. Just keep 92. Okay. Then others not it, just I remove. So these things we simply divide with 1 is 6 to convert square meter to a square kilometer, and further this pixel area we divide.
Why 1 to 1 is 6?
It's a 1 is 10 to the 6, mainly conversion meter square to kilometer square.
Okay. I understand.
Just like copy and paste here.
Meter to kilometer.
Yeah, meters to kilometers. So now further we try to add the layer, then say whatever layer. Okay, so a problem. It compute the area.
And compute area, not population.
Actual value. Okay, I think. Now let me check the result. Suppose it is closing 98%. So it show this type of layer. So it show this type of place is the high dense of population. This type of red color we find out. But this ee.image.pixel area is divided with 1 is 6. Okay, to meter to square kilometer unit. but how it calculate the area? We need to compute the area. So if I just print, suppose print this pixel area, and check what happened. So it's a image, have the one bands, area, it compute the area.
It doesn't calculate the population density.
Okay, population
Maybe
density.
the divided function doesn't.
Yeah. So this pixel area, basically we need to compute the pixel area in our total pixel area. Okay, in Dhaka city boundary. In Dhaka city boundary, we need to compute the total area. And this area we need to divide it with the total number of population. It's stored the total number of population. But in this case, this function we are just use and divide it, but we are not connecting any kinds of area. Basically this ROI is not connected with this variable, with this function. So I think how we can easily add band. Suppose I just add. So now what happened? It's not work. Okay. Or is there any data set to compute that correctly population density? Suppose population density. Yeah, it's yes, it is also available. So this is another data set, population density. Okay, so yeah, so we can also use it, no problem. So it's a population density directly compute. It's a ready-made data set, not need to multiply or divide it anything. So it's just compute. You can see population density, the estimate number of person per square kilometer area. So we can use it without this type of error. Suppose I just use the data and get the result for population density. Just copy the snippet ID. And okay, and then I just remove all of those and take a variable, suppose population density, and paste here. So now further same, just I put here the filter bounds with my study area, which is RY, then put here sum to compute the total, and then clip with my study area, which is RY. So now we display the population density map using this ready-made data.
Density, comma, 7767.
And further you want to add the, suppose just click on here, so stressing 98%, and add the color plated. I was going to show the low density, this type of color, then getter, then use this type of color, then getter, then use this type of yellow color, and high density show this type of red color. Okay, then apply. So now this type of red color indicating about the high density. So you find out, you can see this type of place is the high density of population, then this type of green color, then this type of yellow color, and finally this type of color indicating about the low density of population. Basically this is the cities. In the cities we find out that high density of population. Okay, so now GDP. So GDP basically this GDP we are just use the another data. It's called the nighttime data. Okay, nighttime lights. So nighttime lights data, it's indicating about that, suppose in the nighttime activity, and where you find out the nighttime activity, it means that this type of place is the GDP growth is very high. Okay, in the night time. Okay, suppose in the for the urban cities or urban area, we find out that time. Okay, and this type of activity is indicating about that high GDP growth. Suppose in the high GDP region or cities, we find out that night time there are a lot of activities. Okay, for different types of work. So for that we also use the GDP as a proxy of nighttime light we also use. So for that simply search here another data set. It's called that BIRS. Simply search.
There I have problem.
Yeah, please.
Well, we are using the name of city, not the coordinate. Maybe to calculate by grid cell.
Grid means mainly which country?
Yeah. Well, we are not using the coordinate.
Or which area?
Maybe like to calculation the population density. Why we don't take like a random coordinate and use like this coordinate in this city? I need to check the population live in this city. Why are you only using the name? Like where you showed me the population, like that map you have been shown there, like population density. In some area there are high population density, others medium, others low, and others very low, right?
Okay, so
Then
for the
maybe we need to
you need
calculate,
the
we need to get
coordinate information, yeah.
like in this city, right?
Yeah.
We did it at level of the city. Maybe we needed to take the coordinate in a high population area. Maybe another one. How can we extract the population located in the exact location by using the exact coordinate?
So for the coordinate, we can also get, suppose click on the inspector tab. Then if you check, suppose just click on the map. Suppose just I click on this area.
Yeah.
So then it
There.
show me the coordinate value you can see. Okay. And in this coordinate, how many population?
Oh.
We also find out. Suppose I just click on here. Suppose this type of place, another place. So now for this coordinate, what happened? Yeah.
Then if you have like in the file I shared to you, I have like the exact location. Can I import that photo in the browse by exact coordinate?
Yeah, it also possible.
Like using the one of
yeah.
like sample ID.
Yeah, it also possible. Suppose this is
Okay.
this is my
Let's
coordinate.
continue.
This is my coordinate. So this
Let's continue.
coordinate I want to import also in here and get
Yeah.
the result. It is also possible. Light time data, how we can work.
Okay. Let's continue with the data set.
Okay, so simply search, then you can easily get this type of, we can see nighttime day, this type of data. So this is the nighttime lights data set. We find out this type of data. Suppose I want to use this data.
Nighttime day, there is a lot of data set. Why do you choose this one?
So okay, so basically in this time, this data set is more recent. We find out the data from 2022 is available from here. Okay, just let me open it. So basically it's a version. Okay, different types of data set version. We find out for the different time. So you can see, we find out this is the more updated data. So it's available from 2024. Yeah.
Yeah, I see.
So we can easily use this data. So basically for the different version have the different data set. Suppose this it's available from this 2012. Suppose 2020 at the another data set. Suppose I want to use the data set, just I copy.
Okay, I see.
And then open a new coordinator. And this type of data, if you want, you can also do it for globally, not select any kinds of specific cities or boundary. Suppose Okay, can you hear me? Hello.
Hello.
Okay, can you hear me? Yeah.
Yeah, I can hear
Okay,
you.
so let's go. Okay, let me share my screen. Okay, can you see my screen now? Yeah.
Yeah, I can see your screen.
Okay, thank you. Okay, so just I simply paste the data set in. Oh, sorry, let me paste again. Just copy the data set snippet ID and paste. Okay, so now give a variable name. So I will put the variable name is that night light. So okay, so now if you want, you can simply just add the layer map.add layer and call this night light. Just I copy and paste here. So now this data set is loaded for the whole world globally. You find out, you can check. So you can see globally you find out
Okay.
that it's a globally data set you find out. Okay.
I see.
So in the global data set, if you want to check, so not only for that, a previous two data set when I discuss about that population count and population days, it also available for the globally. We also get this type of data. Okay. So now suppose you can see, you can easily identify this type of which color indicating about that high night light activity. Okay, we can also get. So for that, if you simply stress the data,
I see.
and if you want, you can also apply.
Yeah.
I think this stressing is not good for that. So if you want just, and from this data set, we also get the another band information. If you check the band information in this space, we also find, you can see the average. Okay, so average max. So we just use the average. Okay, average. Basically, it's the average DNB radians value. Okay, so this average band we try to apply. Just I copy the average, this band name, and I just use a function in here. This function called the select function. Okay, just apply the dot select and select this band name average. So now we are just work only for the one
Well,
bands. Yeah,
so
yeah, please.
I have a problem there.
Yeah,
We have many variables, we have many data sets, we have average, we have minimum, maximum.
yeah.
Why did you choose this variable of average?
Average. Okay, so basically this is
We have
band.
many.
This band, it stored the information average reflectance value, average radiance value. Okay, average
Okay.
radiance value. It stored the average radiance value. Mainly in the night time, it show the
Oh,
average radiance
okay.
values.
Okay.
We find out from this average.
Oh, yeah, yeah. It's
So
like
that's,
mini value.
yes. So further we simply take the average,
Okay,
and
okay, I
further we
understand.
simply stress the data. And then suppose I want to add the color. Suppose I want to add the this type of color where I find out the low activity or low night time. Then suppose I want to add this type of color.
Yeah.
Suppose greater than, I just use this type of yellow color. Then suppose I want to use this type of red color. So it's the high activity, high night light activity. We find out. So it show this type of map. I think this map is
I
not good.
can't see your screen.
Oh, just a minute. I think this map, this color is not more appropriate for this. So let me show you the another color combination. Then it will look more perfect. So I think we try to add the color for this. We try to apply the white color. Or stressing all 3 sigma. I just put. Okay, check what happened. Yes. So now it also okay. No problem. So basically this type of red color indicating about the high activity in the night time. This type of red color,
Yeah, I know.
indicating about that.
I know, I know.
So we can see this type of red color indicating about the high night time activity for this. So if you want, you can also check the result. Just click on the next tab and click. So then we can easily get the coordinate values for this place. Click on here. So then we find out the coordinates values. But you want to work with some specific cities or specific countries, not for the whole world. Suppose I want to check only for the suppose United States I want to work. Okay, so I need the shapefile of this boundary. So for that, what can I do? Just I simply import the shapefile from US website. We can easily get this dataset, international country boundary polygon. Okay, so this dataset I need only for this specific study area. Suppose I put the ROI and put the table, and this table I want to filter. How I can filter? Earth engine dot filter dot equal what's equal what. So put here country name and put the country name, suppose United States. So now further, what can I do? Just I simply suppose just for the United States I compute suppose average radians, then put the clip with my study area which is ROI. So now run the code. So now this result is FARate only for the United States. We find out, we can see. So without color it look like that. We find out this type of white color indicating about that high night lights. We find out this type of color. Okay, it's indicating. So further, if you want, you can also add the color to visualize this map. Suppose I add the two color. Suppose one color show this type of color I have to show, and another color I will show this type of color. Just apply. So now you find out this type of color indicating about that high light activity, or apply suppose this type of yellow color. So now we find out this type of yellow color indicating about the high night light activity. We find out, okay, this type of place.
I see.
And if you want, you can also use, suppose in this time I want to work only for this type of place where I find out the high night light activities. I find out, suppose I want to work only for this type of cities. I want to select, or I want to get the information only for this type of place. So other place I don't need. So it also possible. It also another way. We just try to extract only for the high light time activities in place. We find out. So for that, just apply a threshold values. Suppose in this case, if you check the, just click on here, we find out the values. It show the values. We find out the 3.59 something, this type of values we find out that. Or if you check, suppose just click on here, it show that 70. Okay, if you check suppose this type of color, it show the 0. Or if you want, you can also add the value. Suppose in this case I want to choose, suppose take a variable, suppose I put the variable name is that high GDP area. Okay, and I call the night light, and I choose the value, suppose greater than. If you check this type of place, have the value is that 1.8. So I put the suppose greater than, I considered suppose greater than 1. Okay, I could just greater than all of place where the values greater than 1 I consider as a high GTP area. So this area I want to visualize.
Okay.
Only I want to visualize. Suppose for that map.add layer, and then apply the high GTP area. High GTP area I consider as a high light time activities. Okay, and then I want to add the color plated. Suppose plated, I put the color suppose as a orange color, and apply the self marks function to remove the background of this map. So now run the code. So now it's created. You can see some map look like that. So in this time we find out that this type of orange color, it's indicating about that high GDP area. High GDP area we consider as a high night light time activity. We find out this type of area, or this type of place we find out.
I understand.
So we find out this type of place. So this is another way. If you want, you can also choose a threshold value, and further you can simply choose only for this type of area. Suppose in this case we find out this is one kind of area, it's a high, suppose it's one kind of cities, this is another kind of cities. So basically this type of cities we find out that high night light time activities. Okay, this type of cities area.
Yeah, for sure.
But you can say other for the
Yeah, for
forest
sure.
or hilly region, there is not much. Okay, we find out only for this type of place. If you zoom, then you can get the more better. Okay, this type of cities area, we find out that. Okay, this type of place, we find out that high night light time activities. So that's why this type of place GDP growth is very high.
Yeah, for sure.
And same case, we also do it for suppose other previous two data set. Suppose high population, you simply choose a threshold value, suppose greater than 100 people or greater than 1.2 square kilometer. So this type of things are also possible to create, to identify for the zone. Okay, so this type of zone, we find out that high night light time activities.
Okay.
So this type of social factor we also use, suppose nighttime activity, then population growth, and also population density. Okay, you can simply search the data set for the population growth or population density. Just apply the same way. Okay, same method we can easily generate. So now
Yeah,
how I can,
it's the same way.
yeah, same way. All of this the same way. Just we need to
I see.
just change the dataset snippet ID and also choose the band name. Okay, and others keep the almost same, not much any difference. So now suppose I want to export this type of data. Suppose this data I want to export. Suppose this map, you can see that the two layer. So this is the layer. So it's show the all of values. Okay, all of values. So from all of values, I simply separate this type of values to identify high night light time activities. So they are the two layer. Suppose this type of layer I want to export. Further, I just use the ArcMap or QGIS software to produce the map for my research paper or presentation. So further, we also use the another option. It's called the export image to tribe. So this function, we simply write, it's called, you can simply search here all of function in here. Suppose export image to tribe. So this
Oh,
function.
you need to export in the entire format.
So it's a geotiff.
How if you need to export like in TIF format?
Which format?
TIF.
Yeah, TIF. I'll show you this process. You can see TIF format process. So this function
Because
is,
I thought in TIF it's possible to extract these data from map.
yes. So basically just
Like
download
using
the data as a
Python.
TIFF format. Okay, TIFF format. So for that this TIFF format, we can easily use the ArcMap or any other geospatial software we can use and
Okay,
further
okay.
make the analysis, more analysis.
Okay.
So,
Okay. I understand.
yeah, so now from this is the function we simply use export image to tribe. So first condition is the image. Okay, so image basically which image you want to download. So in this time you can see there are the two layer. So this is the first layer, this is the first layer, this is the second layer. So which layer you want to store it? Suppose second layer I want to export. So second layer is stored in a variable. Just find out the variable name. So this variable stored this second layer. Okay, this second layer is stored in this variable. This variable, because you can see when I add the layer of this variable, then it display this type of map, second layer map we find out. So this second layer is stored in this variable. Just copy the variable name and write here. And description, it can be anything. So you can put any name. Suppose I put the name, it's a high GDP area. Then folder, you can put any folder name. Suppose I put the GE without a space, we can put any folder name. So file name previous is not need. Then region basically shapefile variable name. So in this case, my shapefile is the ROI. So just I put the ROI because ROI is stored at the United States boundary.
Not exported.
Yeah, so put the ROI. Then scale is the resolution of this satellite data. So this satellite data, what the resolution? So this information we find out from this data set. If you simply search the data set again, VIIRS. So if you check this, where is the data? Yeah, night daytime. So this data set. If you check the bands, so we find out this is the resolution or pixel size. So just use it. Okay, 463 point something 83. This is the resolution. Just I put this resolution at a scale. Then CRS it's not need, and others is not need. Okay, so it's optional. Okay, this type of argument is not mandatory. So when you export this file, we find out the geotiff file. it so the result is the TIFF format. So further this TIFF form is simply just run the code. So when you run the code, then our task tab will be running. You can see the task tab will be running. So from this task tab, simply run. So now this file is exported as a GeoTIFF file format. Just I run it.
Okay, I see.
And further simply work with the ArcMap or QGIS software to make the more analysis or create the map, proper map for your research paper or presentation. Yes, again, running. Okay, so can you, okay, so it's okay, yeah. So you can see now it's downloading.
I see. Mhm.
So now it takes some time.
It is downloading the one of the USA only.
Yeah, only for the USA. Suppose you need this result for the other countries, so simply change the country name. Suppose I need the result for Bangladesh, so simply change the name or any country.
Oh, it's easy.
Yeah, Bangladesh.
It's only to change the name of country.
So now we can get the result for Bangladesh, but it not focus the Bangladesh boundary. So just let me add the another line. Suppose map dot center object. Object is ry. Zoom level was 10 and run the code. So now you find out this result. So now I can see you find out this.
This is the map from Bangladesh.
So now you can simply show the result. So now you can see find out the all of major cities. So you can see this is the night light time map. While we find out that high, and you can see when you just apply the values, find out this type of place have the more night light activities in Bangladesh.
Yeah, for sure. I see. Take time.
Yeah, so now I can see it will be working. I think it's downloading. Also downloaded. So it's also take the some time, 5 minutes or 10 minutes, then it will be downloaded. Suppose now we downloaded all of so just run it. So now download it for it. So any country. Suppose I need the result for another country. So simply put the country name. Suppose I need the result for this one.
Once you have the code, you can learn everything. Like,
Suppose Australia. Just run on the go. So now you find out that Australia nightlight activities. So now you can get this type of place where if the high nightlight activity, you can easily find out.
I see. I see.
So this is the process to working with the three argument and the three factor: population density, population number, and population and nighttime activities. Okay, so you have to try to use this type of data.
Yes, I see.
Okay, so now I'll try to show you the another factors. Suppose climate factor and work. Suppose climate factor, and then we try to check suppose mean annual temperature, mean annual precipitation, or so let's go. This type of things we also get it from the another source. Let me show you the another code editor. Just open the code editor. So now if you check the result, simply search here world or world, yeah, so dynamic world, no, it's a world bioclimatic. Or simply search here suppose ERA5. So ERA5, you can find out, you can see different types of ERA5: daily data, monthly data, hourly data. Okay, so this type of data you can easily use. Suppose just I use the daily data and then click on here, then get the all of information about this daily data. So this data set, we find out this type of reanalysis data. Okay, this reanalysis data, if you check the band name, so you find out that air temperature, so this is the mean 2-meter air temperature, maximum or average, then total precipitation. It's provided a lot of information we find out. Okay, can you hear me?
Yes, I can hear you.
Okay, so let's okay, so you can check, we can easily get this type of information. Suppose air temperature, 2-meter height. Okay, average air temperature, 2-meter height. So this is the temperature, we can get the rated from here. So just simple way, just copy
Yes.
the snippet ID again from here and then open it in a new code editor. Just paste. Okay, and take a variable name. Suppose I put the variable name is dataset, and then select the band. Okay, just use the select function and select the band name. Suppose mean 2-meter air temperature, this band. Just copy and then paste here. So now if I just run the add the layer, so then we can easily get the result for the whole worldwide information for this data set. Where is the high temperature, air temperature, you can easily get this type of information from here.
Okay.
So now it's loaded.
I see.
And if you want, you can also choose the time period also. Suppose I want to use the filter date function and choose the specific time. This data set is available from 1979 to 2020 or 2020. So I take that from suppose 1 year data, suppose year of 2019, 1st January from 2019, suppose December 31. So now let's check the data. Just we can get the 1 year data for whole world. Where is the high temperature, where is the low temperature? So you can easily get the idea from this globally. And if you want, you can also add the color.
So I have a question. If you select the data like this,
yeah,
it provides you the mean annual average, mean average for annual.
So this is this result show for the average. Okay, average global average data.
Okay.
So now if you check the map, it show the result for the globally.
I see.
And further, suppose you want to work only for the one cities or one countries. Okay, suppose I want to work for countries. So same process, just simply call the data US DOS and then import, and further just filter. Okay, filter your specific boundary or country. So take a variable, suppose ROI. So then just call the table and filter. So earth engine dot filter dot equal. So now put the country NA. Suppose I put the country name is for suppose Australia. Just I put Australia. So now for that, simply use a function in here. So just put here suppose I calculate in Australia average, so mean, and then click with my study area, which is ROI. So now run the code. So now we can get the result only for the Australia boundary. So I can see you can get this type of map, and it's a air temperature. It will be more better if you just stress the data. Suppose just I stress the data 98%.
Okay, I see.
And then apply. So now you can see this type of color indicating about the very high temperature, air temperature. It's the air temperature, and this type of place is the low color. So you can see this type of map we find out for the air temperature. And if you want to check for every coordinate, just click on here and click on this map. Then we find out this for this coordinate, what's the air temperature we find out. Okay, we can easily get this type of information. Yeah, please.
So for I have a problem.
Yeah, please.
Isn't there anywhere you can import your coordinate?
Yeah.
Your file, or maybe in this CSV.
Yeah.
And then get data using this coordinate format.
Yes. It also possible. Suppose you have some coordinate. Suppose you have a CSV file. In the CSV file, you have some latitude. Suppose you need the lat column and also need the long column. Okay, so this lat column and long column, if you have, so this type of CSV file you can easily import. And further you can simply extract, suppose this type of result for a specific coordinate, what's the air temperature value. Okay, we can easily find out. So it is also possible, same process. So you can just ready a lat long value and create a CSV file, then send me. Then I also try to show you the for another session how we can easily work to get this type of data for the specific coordinate.
Yeah, that's the last time I remember. That time I sent you the files.
Okay,
I
so
was maybe expecting.
Okay, you can send me the CSV file basically only for the 2 column lat long, other column not need. Otherwise it will be very high.
No,
just send me the lat long values in CSV
I mean,
file.
the last time I sent you my data set.
Yeah.
You requested me to send you my data set. I did, and I sent to you. I was maybe expecting to get maybe some more knowledge of how using those data set.
Okay, is it only for the lat long values or other value also include? So is it only for the lat long in your CSV file or others values also have?
Don't you open the file that you requested me to send on the November 4th?
Okay, so you send me the one file. Let me check.
I send you the file. You requested me to send you the file and also the sample.
Okay, data set by the year.
Yeah. You told me to extract it by year. I did.
Yeah, so in the year file, okay, let me check. Is there? Okay, let
And
me
you
check
told
the
me maybe
data.
last time that you will show me how you organize my data based on the data I sent to you.
Okay, so 2023 server sales. Will I just open? Okay, this is there is a lot of information. Latitude, longitude. Okay.
Yeah, because you don't you remember you asked me to send the whole data set, including all of my data.
Hmm.
Maybe you had a lot of time these days, so you didn't get time to overview it.
Okay, so we try to import this type of data in the Google Earth engine, then check what happens. So was latitude, longitude column have this type of data. So we try to open, and it's easy, no problem. We try to export this type of data as a CSV file. Suppose for the specific coordinate, suppose I have some specific coordinate, suppose in this cities, suppose this one. So I have this type of point for the specific coordinate. So then we can easily export this type of data for the specific coordinate. What is the value of air temperature at the 2 meter height? It will be possible. No problem.
Thought you will run and doing it. I will see the session.
Okay. Okay, so this is the air
Yeah.
temperature. We can also get from here this type of way, this data set. And further, if you check the another, so world bioclimatic variable is very important. So if you simply search here in the search bar, suppose world bioclim, you can see there's a lot of, we find out world bioclimatic variable like that.
Yes.
So you find out that annual mean temperature. Okay, this is the bio 01. Then also find out that maximum temperature, minimum temperature. Then also find out that annual precipitation. So it provides a lot of information from this when we find out. So this is the, we can easily use it. Just I copy the same line of snippet ID of this data set. Just paste here and take a variable. So I put the variable name is data set. And this variable, if you check, this data set have some bend. So BioGeo1, it's a annual mean temperature. Just a copy BioGeo1 and then select. So put here to the dot select function and paste this BioGeo1. And further, if you want, you can also display the map. So just use a map.layer and call the data set and run that. So it looked like that. And if you want, you can also add the color, plate it. I'll just paste here and copy and paste after the object name, and I put it's a annual mean temperature. So it look like that. Just let me tracing the data. So we find out this type of visualization. Okay, so it show the globally. We find out the globally annual mean temperature. So same process, just simply work for the specific boundary or a specific coordinate. Just apply the same process, then it will be work. No problem. Okay, can you hear me? Hello, 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 can you hear me?
Don't you hear me?
Yeah, I can hear you now.
I hear you.
Okay.
Yeah, I hear you.
So if you check this type of point, so you already send me this type of point, and I already uploaded
sure.
this data. Suppose now I want to extract the mean temperature, annual mean temperature, only for this type of point. So you can say I already add the map, look like that, and it just show the result only for this some point, also some point in here. So we can easily export the temperature, suppose only for the specific point. Okay, so for that here I already imported the points. Okay, so I want to export this type of result. So if you want, you can also click the manually, but it's not the proper way to get the result. But you can also extract. So take a variable. Suppose I put the variable name is that values, and then call the dataset because it stored that information, and apply the function. It's called the reduce regions.
Yeah.
And if you check suppose reduce regions, this function. So first just I copy the all of argument and paste. So first argument is the collection. So it's indicating about that your feature collection, mainly points basically all obtaining points, okay, which I have, and reducer. So each point, suppose I want to compute average temperature scale is the resolution. So this resolution, if you check from the resolution for world bioclimatic variable, resolution is this variable 927. So just I put here 927, and others not need, just I remove. So now if I just print, suppose just print this values and run the code. So now you can get the only for this values result from the console tab. So if you check the result from the feature, it's a feature collection, all of points total. We find out that 217 points in this variable, and if you check all of points, extract the information. Okay, mainly this annual mean temperature information we find out. If you check the property, so you can see all of those we find out, as well as it's added the new property, this one. So
Yes, yes.
this property you can see ID payment 26.
But the non-new variable of non
Okay, so where is that information for temperature? So this is the RG log 10, RG bacteria abundance, rare, high risk, sample ID, collection date. Okay, where is the value? Oh, I need to apply the sample regions. No, radius region is also okay. It's regions. Yeah, bio project. I think this column.
that column is a variable like which is I have uh, I have
Yeah, we find out. So this one is for, yeah, we find out the mean. Okay, mean column. Yeah, mean column 84. We find out the mean column. So mean column basically stored the information, okay, for that mean temperature. So I think, so this mean column, yeah, this is the mean column. This mean column stored the information for uh, annual average temperature. Okay, this is the main column. And if you suppose this is the say this okay, this bioclimatic variable unit is degree Celsius, and we need to put this scale also 0.01 to get the better accurate values. Okay, so for that we simply create a function in here, and I put suppose img, and this I just return this img multiply with this value 0.1, and it's just apply the copy properties of this system time start to system time end. So now run the code. Okay, so no need. Multiply. So now you find out that more accurate values. So if you check from the properties, it show the mean, you can see 12 degrees Celsius. Then you check, suppose you find out that properties. Okay, so suppose these things, if you want, you can also apply the another data set. Suppose I want to apply it for this data set. So this is the data set mean temperature. So for that, just simply, it's not need for a specific country. We just try to add it for all of whole world. Okay, so just run the code. So now you can simply import your own points data which you have. Suppose I have this points data here, I already uploaded the data set 23n, just I import table 2, just I put the name, suppose point, I put the points. So I need the information for this point, just I use the same code, suppose just use the same line of code for this. For the starting the all of points values for 2-meter heights air temperature, just I call the data set, okay, data set reduce region points, I just compute. So now if I run the code, okay, the data set I compute, suppose mean average, just run the code. So now if you check the console, now it show the all of result for these points from the features. If you check, you can see the result, you can see mean 286 air temperature, okay. I think this unit is the Kelvin. If you check the this data set,
So I have problem here.
yeah, can you hear me?
What? Yes.
Yeah.
Why this temperature is very high? Is it average month? Is it annual total annual? Is it total annual temperature?
So it show the result for Kelvin unit.
Kelvin.
Yeah, Kelvin.
Kelvin.
Yeah.
Okay.
So when you I'll show you that unit, suppose ECM WF. So this data set basically show the result in the Kelvin unit. Further, you can also convert the unit degree Celsius. So if you check this information, 2-meter, what is the unit? Okay, just a minute. Let me open the information from the hands. Okay, you can see the temperature. K means Kelvin. Okay, K means Kelvin. So it's a Kelvin unit. So that's why we find out this type of high 286. But when you remove suppose 273, then you can get the low temperature. So I'll show you that how we can easily convert the degrees Kelvin to degree Celsius. So for that, simply write a function in here. So just apply the map function and apply the function. So I put the element name img, and then further this just a return this img, subtract a value 273.15. So now it's convert the unit degree Celsius to Kelvin to degree Celsius. So copy properties of this image, apply, and then separate system time start to system time end. So now run the code. So we find out the result in degree Celsius. Ready to show a problem? System time str start. We need to apply the list. So square bracket and also close the bracket. So now run the code. So now we get the result in degree Celsius unit. So now if you check the result again, just check the property 13.74 degrees Celsius. Okay. So this is the way. So just apply the same way all time. After upload your CSV file, then we simply just extract the values for each points. So in this case, we are just extracting only for this type of points, but any data set, you will just apply the same process to working. So same as air temperature, if you check the mean annual temperature or mean annual precipitation, okay, same. Air temperature, just ER5 blend, okay. So then, so now we talk about the wind speed and wind direction, how we can easily compute the wind speed and wind direction. because we need to apply formula in here. So we need the u component of wind, as well as we also need the v component of the wind. Okay, then we can apply the formula, then we can get the wind speed. So let's go try to show you that how we can easily work for that. So let me open new code editor. So simply search here ERA5. And if you check the daily data set, I just try to use it, daily data set ERA5. If you search, then you can get the daily aggregate data set and click on the information to check all of bands information. So from where you can get the one band, so click on the bands. So we find out that u component of wind and v component of wind, meter per second. Okay, so basically these two band we need when you work for air temperature. So just I copy the snippet of this data. So it provides the daily air temperature information using this data, so they find out. And further just take a variable, suppose data set, then paste here. So now from this data set I take a variable, suppose u equal, I call the data set and then select the band basically u band and v band. We can easily get it. U component daily cover average, u component of wind 10 meter, just take copy and paste here. Then same, just take the another variable, suppose v, then I call the data set and select the v component of wind. So we can just copy the v component of wind, this variable band name, and paste. Okay, just paste. So that we simply choose the u and v component, and then finally just apply the formula of wind speed. So wind speed and also wind direction, two things we need. Okay, so for the wind speed, so take a variable, suppose wind speed, and just call the u, then put that v. And I rename it as a, so it's a wind speed, put the wind speed. So now we try to add the wind speed there. So take a variable, just call that and run the code. Okay, it's a problem. Let me check. Or we can also directly put the equation. Suppose u POW power 2 u square. So we just apply the formula.
Okay.
U square plus mainly add v square, then whole equation is square root. So put the bracket and also close the bracket, dot sqrt square root. Okay, so now let's check what happened. No, it's not working. It's a problem. Okay, let me check. So wind speed meter per second. So let me add the color. Suppose for only for the Bangladesh, try to check and add the color. Suppose I want to add this type of color for low wind speed. Then get it, then use this type of color. Then get it, then this type of color. Then get it, then this type of, and high wind speed I want to show this type of red color.
Okay.
And then apply.
The same value. Yeah, the same value.
Yes.
What will change? Maybe see due to letter. It means near the coast of the sea, they have wind.
Yes. So we find out this type of place is the high.
Yeah.
Okay. You can also just spacing suppose 3 sigma and check what happened. We find out this type of map for wind speed. And for the wind direction, if you check wind direction, let me open this layer only, wind direction. And if you check the code, so this is the wind speed. And for the wind direction, it's wind direction. So use this radians 0 at east, multiply 180 divided by math pi values.
Nice. On direction.
So here I already compute all of those factors for the only for the Bangladesh country boundary.
It cannot be applicable for global map.
Yes.
Cannot be applicable for global map.
Which one?
This one of the wind direction.
Yeah. So let me add the color. Suppose I add the two color.
Oh, one touch is low.
Yeah.